is attention. As you know, from last week, the exam got moved to a week from today rather than today. Just to give you, let me give you a practical situation to make clear what the issues are in attention. Generally think that more information you have, the better it is. In any kind of situation, you're trying to decide what to do, trying to figure out what a situation is. The more information you have, the better that is. Well, that's not true. As a matter of fact, couldn't be more wrong. At least for real life, on the spot, high speed decision making, where you've got to figure out what to do right now. Lots of information can be just as much of a problem as too little information. I get wheeled into an emergency room. Had 3 to 5 hours of intermittent left side chest pain when he tries to walk up the stairs in his house. Chest exam is normal, though. Heart exam is normal. EKG, the electrocardiogram, which is where they put the electrodes in your chest and measure your heartbeat, that's normal. Systolic blood pressure is 165. If you know about blood pressure, it's one over the other. Systolic is the top one, which is the blood pressure when your heart is constricted. Diastolic is when it is the blood pressure when your heart is relaxing. Systolic blood pressure 165 is a little high, but it could get that way when somebody is scared or very nervous or very excited. Guy's in his 60s. His job is real hard-charging, high-powered executive. Constantly under pressure. Smokes. Doesn't exercise. Actually, his blood pressure, it's not just that this one reading is 165. You discover he's had high blood pressure for years. He's overweight. And he had heart surgery 2 years ago. What's your diagnosis? What's the matter with him? Heartbeat. Having a heart attack, of course. Wrong. Too much information. Most of those factors on the last slide don't indicate that somebody's having a heart attack. They indicate that he's liable to have a heart attack sometime in the next 2 years, but not right now when he's being wheeled into the emergency room. And emergency room attendants, nurses, doctors make the same kind of mistake all the time. And something may indicate that something bad is going to happen to the person, and they assume it's happening right now. But the symptoms of a heart attack, while it's going on, are actually different. Not all of that information. There was one statistical study where they just sat down with thousands and thousands and thousands of admissions to emergency rooms and saw what the characteristics were of just statistically, what the characteristics were of somebody who was actually having a heart attack. And what you need to pay attention to is the EKG, which is one of the things, like a cardiogram, the electrodes that measure the activity of your heart. Blood pressure should be looked at, which it was. You should check for fluid in the lungs. That's an important characteristic of somebody having a heart attack. All you have to do to check it is just take a stethoscope and put it on the person's chest and listen while they breathe. But that's a very important diagnostic factor of somebody who's actually having a heart attack. Last one is unstable angina, which means heart pain that stops and starts. Angina is heart pain, and unstable, obviously, is it. Those are the only four things you should pay attention to when somebody's wheeled into an emergency room and you want to figure out if right now he's having a heart attack. That often gets misdiagnosed because there is so much other information there that is so salient. Salient means stands out. But look at all this stuff that all of this information that I gave you in the 60s, not really. Hard charging executive constantly under pressure, that means sometime in the next few years he's liable to have a heart attack, but that doesn't mean he's having one right now. All of this information is very plausible, but there's just too much of it. It gets in the way. What you need to do is know which parts of this information to pay attention to and which parts of it to ignore. That's one of the most important cognitive processes there is knowing what to pay attention to and what to block out. I stole that from Blink, by the way, one of the books that I showed you the first day. I thought it was a great example. It's not only important to focus on all the relevant information, all the important information, it's just as important to focus to eliminate irrelevant information. Not just in this example, but any kind of real-life decision. Everybody knows we need to focus on what's relevant and try to get as much information as possible, but that's a mistake. What we need to do is have some knowledge or some other way of saying this is important, we need that, but this is not important, this is misleading, don't pay attention to this. And that's just true all the time in everyday life. I think I mentioned right at the end of class last time that actually one theory of schizophrenia, not a really popular one, but one theory of schizophrenia is based on the idea that a lot of the problems schizophrenics have is the inability to filter out too much information. So too much of it gets in, inability to filter out unimportant information, so everything just gets in, overwhelms them, and just locks up the whole system. It causes all sorts of malfunctions. I'm not saying that because that's the best theory of schizophrenia, but because whoever came up with it is thinking in terms of how attention actually works and how important it really is. It could conceivably create a lot of difficulties in schizophrenia if we weren't able to block information out the way any normally functioning person can do. It just doesn't seem like it's that important, but there are really few cognitive processes that are any more important than this, knowing what to focus on and what to leave out. It's also a very tricky one, theoretically very tricky, very difficult to figure out. And you think, well, you either pay attention or you don't? What's the issue? As I said again at the end of class last time, just leading into this, how do we know what to pay attention to if we haven't paid attention to it yet? Somehow or another, we can block things out. We can know that a lot of things are irrelevant, and we don't want to get confused by them. And we can tell that even before we think about it. We know not to pay attention to it. A really important cognitive skill we have is knowing what not to pay attention to. But how do we know that if we haven't paid attention to it? How do we know what it is? That turns out to be a really tricky question. And the early ideas about it came after World War II in studies by the British Navy. Because the reason this first came up then was World War II was really the first high-tech war. Radio communications, radar, fighting machines that actually flew and landed on ships. None of that before the 40s existed. And so here are all of these military operators that just have all this new information, new types of information that they've got to contend with, and nobody knows how to help them. Nobody understands what this kind of information overload does on the ability of people to think and function and decide. And so the early studies of this were for very practical reasons, where, for example, somebody's in the conning tower of a boat or in a cockpit of an airplane. You got a message coming in here, message coming in here, message coming in here, message coming in here, and some kind of printing device putting out a message here. How much of that can a person handle? How much of that can a human operator digest without it starting to interfere with each other and blocking up the system and actually causing more trouble than it prevents? Well, a guy named Colin Cherry in the early 1950s started on the problem by thinking as the kind of prototypical situation. You're in a cocktail party, or you're standing out here waiting for a class to start. You're in some situation where there are like 50 conversations going on. You can pay attention to any one of the 50, but only one of the 50. You can listen to this one, you can listen to that one, you can listen to that one, and you can completely freely choose which one to pay attention to, but you discover you can't pay attention to more than one. Then everything just falls apart. So how do you know which conversation to pay attention to? He figured if he could figure this out, he would at least make a good start on getting some foothold on attention research. Referred to this actually as a cocktail party phenomenon. Now he wants to rigorously, carefully study this in the lab. So he has to figure out what he might come up with in a controlled laboratory situation that would simulate this kind of thing. What would you do? Say you want to do this for your honors thesis or your master's thesis. You want to take this thing that everybody knows about, but you want to create a situation where you've got enough control over it to study it rigorously. What would you think of? Kind of hard, actually, but he came up with a just very simple solution. He had people put on headphones. One message would go into one ear,
a separate message would go into the other ear. He would ask the sailors, these were all done in British sailors, would ask the sailor to listen to the message coming in one ear, and then after that had been done, ask him what he heard about what he could tell about the message coming in from the other ear. Have two messages coming in. This one's coming in, and I pay attention to it. This one I have paid no attention to at all because I'm concentrating on this one. Then the psychologist asked me, what was in this message you were not paying attention to? What he's trying to study is how much information we can pick up without paying attention to it. Only one problem with that is that you don't do this very long. I said the right ear and left ear as examples. Half of the subjects would have been one way and half the other way. But for this to really work, for this to give us results that other people are going to have faith in and pay attention to, we have to know that the person really was paying attention to the information coming in the right ear. And so when we ask them about what they heard in the left ear, we know they weren't paying attention to it. How can we guarantee that? How can we guarantee that the person is paying attention to the right ear so we can get a legitimate measure of what they heard without paying attention to it? You could ask them questions about what they heard and use that as an after-the-fact test, but it would be better if we could have some online measure where we knew that every instant they were paying attention to the right ear. And it's kind of same theory as that. You just had them repeat it. Now that doesn't sound very hard, but if you're driving home today, listening to the radio, listening to a tape, if somebody's talking even moderately fast, try to repeat what they say and keep up with them. It's terrible. It's incredibly difficult, and it takes like every ounce of your concentration. Maybe you want to park before you try this particular experiment. But what he did was what he called shadowing one of the messages. Say the one that was coming in the right ear, and then do that for a short time, and then ask people, I hear this message come in, I'm repeating it, trying to keep up with the speaker, terribly difficult and attention demanding, and then after that, this guy asked me what came in the other ear, the one that I wasn't following, the one I wasn't paying any attention to. What do you want to? What would you guess in that kind of situation you would pick up from the unattended ear? What would you pick up from the message that you weren't paying attention to? Nothing. That's one possibility. You didn't even hear it. Or maybe we could pick up all of that information without paying attention. We don't realize it, but maybe we do a lot better than we think. Or maybe it's something in between. What would you guess we do with the unattended ear?
Maybe you could be trying to concentrate on one side, but on the other side, things that are more specific to your interest might pop out.
That's one possibility, but how would it pop out if you didn't hear it first? How would you know that it's something related to your interests? Your answer is a good one, but this complication is the downfall of almost any simple solution to the attention problem. How do you know that was something that matters to you if you didn't hear it already?
Last time I mentioned that, so maybe it's some conscious thought since your brain processes so fast. Maybe it processes what you heard before you're consciously aware of what you heard.
That's getting to be a pretty complicated complicated theory for somebody that's listening on two headphones.
It's pretty complicated.
But it's pretty complicated. That's exactly right, and we're gonna go there. That's gonna be one of the major theories we end up with. We're gonna get into conscious processing and unconscious processing, which is just not what you expect. Maybe you expect this from Freud. You just don't expect this from the British Navy trying to study radio operators. But that's the kind of thing we're gonna have to go to. What they found. This question, what is remembered about the unattended, non-shadowed message? And the answer is, you remember what it sounded like. You remember how loud it was, whether it was a man or a woman, where it was coming from, but nothing about the content. Okay, so there's something fundamentally different about processing what the voice sounded like and processing what the voice said. In this simple experiment, Cherry found no problem describing everything about the sound of the voice. But in at least his experiments, they couldn't say anything about, they did that without being able to say anything about what it was the voice said. As a matter of fact, Cherry was really surprised with that, as I would have been too. They decided to push it and had the unattended message changed from English to German. And none of these sailors spoke German. So the voice is changing from a language they knew to a language they didn't know. And then he said, did you notice anything about that voice? Yeah, it was a man, and he was talking loud, and it sounded like it was from over here. Still the same thing. He could say everything about what the nature of the voice sounded like. He didn't even notice that it had switched from English to German. He didn't even notice that it switched from a language he understood to a language he didn't. So,
is there a reason why you upload also the integrity, just in case when we're writing and we miss some of the things that you say?
Yes, that's exactly the point. That's one reason we had to move the exam back, because I'm going so much slower than I would normally go, because I know you'll have a recording of it you can check. Now I know you don't, so I want to be more sure you get it. But yes, that's a good example. And this was really quite amazing to everybody back then. Nobody anticipated that it would be this total of a blockout on one. This total of a blockout for meaning, there's no blockout at all on sound, on what it sounded like. You hear it just fine, you just can't tell what it's saying. It's like the message somehow gets processed at a noise level, but gets blocked from a meaning processing level somehow. Okay, now to talk about, we're going to talk about three theories about how this happened. And so we're going to have to come up with some simple information processing theory of how the mind works. So we can say, well, no, we think the attending is here, no, the attending is here, no, the attending is here. So here is a really oversimplified diagram of the way the mind works in this particular kind of information processing situation. Now, I emphasize this is way oversimplified, but it'll get us through through the discussion of just exactly where in this attention works. Attention, information comes into the senses, and apparently it's not blocked at all. It's not filtered at all. You can tell whether the voice is loud, the voice is soft, man, woman, anything about it, whether it sounds like they've got a sore throat or a cold even. So all of the information about what it looks like and what it sounds like get in. Then we'll talk about this some more later on. There is our first memory system, which is called a sensory register. In the case of in the case of vision, it only lasts like a fourth of a second. Anytime you see something quickly, see something in a flash of a flash of lightning, or just catch something in a glimpse down the hall, it looks like you're seeing it a fourth of a second longer than you're really seeing it. But now, a fourth of a second doesn't sound like, why would you even call that a memory? Because to the visual system, that extra fourth of a second is really important. The visual system can process a lot more with that extra fourth of a second than it could without that extra fourth of a second. In hearing, it lasts much longer. Nobody really knows why, but more like 10 seconds. It's like when somebody says something to you and you hear the noise of their voice, but you didn't understand what they say, you start to say, what did you say? But before you even get the what out, all of a sudden it dawns on you what they said. You heard the noise, you didn't understand the noise, and then you understood the noise. What happened to the noise during that span of time between when you heard it and when you understood it? Well, it had to be somewhere. It had to be stored somewhere for that 2 or 3 or 4 seconds. So what apparently happens is noise comes in, and then we kind of store that noise for a few seconds while we're still trying to recognize it. And then we either don't recognize it or we do recognize it on the basis of this 2 or 3 or 4 second, up to 10 second memory for what it was we heard. That goes by a lot of those kinds of very brief early on memories to give the senses a little more time to work. Goes by different names for different senses, as a matter of fact. We'll just call it the sensory register, which is one name for it. Senses analyze everything. Pretty much everything that the senses analyze gets passed to the sensory register. So we haven't lost any information yet by the time we get to this very, very, very brief memory. Then, the process of pattern recognition is to take this information we're seeing or hearing and matching it to our memories, finding a template or feature list or whatever it is that will enable us to know what that sound was. So we got the sound here, we got permanent memory over here, and looking for a match between some characteristic of the sound of the visual pattern with something that we know, with something that's stored away in our permanent long-term memory. One place attention could take place is by selecting some of this, not letting all of the information from the sensory register into long-term memory. Maybe that would overload long-term memory, so maybe we have some mechanism for cutting down on the information at this point. Maybe that's where attention is. A theory, but that's a possibility. Then this process of matching what we're seeing to some, whatever the representation is that we match it to, is pattern recognition, the topic that we just studied last time. But then there is also what we're thinking about right now, which is called short-term or working memory. How many windows does the front of your house have toward the street? You had that information in your permanent long-term memory, very easily accessible, but you weren't thinking about it right now. When I asked you the question, you did think about it, activated the information in long-term memory, and brought it into conscious working short-term memory, where you were going to do something with it. You were waiting to see why I asked you that question. Okay, so you have the senses, you have sensory register, permanent long-term memory, working or short-term memory. Attention could take place at any of those points. We pretty much eliminated it taking place here and here by the fact that that somebody can tell all of the sensory aspects of it. But first theory was that attention takes place somehow early in the system, but not late in the system. That's the first theory, and it's going to be wrong, but it's a good psychological theory because it makes specific predictions so you'd be able to disprove it if it was wrong. Unfortunately, it was wrong and immediately disproven, but that's still, there's nothing wrong with that. A good theory is one where you can tell whether it's right or wrong. And then there is another process that is in control of this. I just called it the executive system that directs attention. It's actually the frontal lobe, and especially the prefrontal lobe, that is in charge of all of this, that decides what we're going to do. First, let me just quickly tell you what it is and then go back to a PowerPoint of it. The idea is, okay, everything seems to get through the senses, everything seems to get through the sensory register. Maybe not everything gets through to permanent memory. Stated in more everyday terms, we see everything, we hear everything, but we don't necessarily recognize everything. This theory was by another, the head of the National British Research Institute at the time, Donald Broadbent, who said, you know, the way it probably works is that there is a protective filter in there, some kind of biological process that serves as a filter to keep the system from getting overloaded. That only lets through certain information instead of letting too much get through. Now, the idea of electronic filters, even in the early 50s, was pretty commonplace, because when you're listening to an FM radio and it starts sounding kind of staticky and unclear, you can push a button and all of a sudden it clears up. Well, what that button does is kick in an electronic filter that blocks out the static but lets the signal through. You don't need it when you don't have a lot of static. When you do have a lot of static, you push the button, the filter jumps up and lets the signal through, but not the static. Broadbent says attention must be some kind of filter like that. We're getting too much information coming in, and this filter jumps in and blocks the information that is just static, the information that we don't care about. Now, the filter, in his theory, which is based on Cherry's work and a lot of stuff before that, apparently we can set the filter to let through anything with these physical characteristics. That is, let through anything that sounds like this. Block out everything except the stuff that's coming from the loud guy with the gravelly voice. Let it through. You know, it's like tuning your radio. I want this information to come through. I want to block out everything else. What we do, the executive system sets the filter to let through anything that sounds like this guy with the gravelly loud voice over here. Let it through and block everything else. Okay, now let's pay attention to the woman who's speaking very quietly in kind of a whispery voice. So the filter gets rearranged, blocks everything except that particular woman's voice. It's just the filter is not very smart because all it's doing is letting through particular sounds. We haven't gotten to the understanding part yet, that the filter can be set to sound characteristics, block all the other sounds but let this one sound characteristic through. And that's basically how attention works. We set the filter to pass a certain sound without understanding the sound at all. No comprehension at all at this point. And then, later in the process, we understand what that one voice that the filter let through, we understand what that voice said.
He must have had kids.
That's theory number. That's theory number 2. That's the theory that Broadbent's graduate student proposed after she disproved this one in a desperate scramble to save herself. Oh, get to that in just a second. The important thing in this theory was that the filter only blocks on the basis of sound. It doesn't block on the basis of meaning. It doesn't block meanings that I don't care about. It doesn't block messages that I don't think are important. It doesn't block things that I don't want to know. All it can block are sounds. It can be set to block certain sounds. Only let one sound get through, and then later the delicate understanding mechanism only has that one sound to analyze. The filter blocks all of the other noise, lets only one noise get through, and then the understanding system, the pattern recognition system, only has to deal with that one voice. But before that, meaning or importance doesn't enter into it. So, here's the system that we were just looking at. What Broadbent's theory says is that the selection takes place right there because a filter is inserted into the system where the filter is set to block all of the noises except one. And that one noise gets through, is matched to permanent memory by template matching or feature matching or whatever pattern recognition system is operating. And the filter is actually there to protect the delicate pattern recognition process so it doesn't get jammed up. And to understand what Broadbent is saying, you understand that the filter does not block the noise. We hear the noise and know what the voice sounds like or the message looks like or whatever it is. It doesn't block the noise. We hear everything. It just takes all of those noises or all of those visual stimuli and prevents them from getting to the meaning analysis system. Like there's a meaning there's a what does it look like system, and there's a what does it mean system, and the filter doesn't block any of the what does it sound like information. It just doesn't let it all get to the meaning system. So we hear it as noise, but it's just nonsense, except for the one that we let get to the meaning system, and that's the one we understand. The problem with this theory was the idea that things we hear get completely blocked from the meaning system. If Broadbent's theory is literally true, we could never tell what a voice was saying except for the one voice we were paying attention to. We shouldn't know anything about what the other voices were saying, although we could hear them. We couldn't even tell, at Cherry's experiment, if they were switching from English to German. The problem was that wasn't true. A woman named Anne Treisman, who was, in fact, Broadbent's graduate student, was trying to test his theory a little more, did the same dichotic listing experiment. They're listening to, for example, the right ears. Some are really getting the right ear, some are getting the left, but let's just say the right ear. They're shadowing the message that's coming in the right ear. They don't know what the other message is saying. They don't even know what language that it's being spoken in. But then let's say the guy's name is Joe. Inserted into this message that they can't even tell is English or German is the expression, "Hey Joe, listen over here." And all of a sudden, Joe listens over there. Everything, no meaning, no kinds of meaning are processed from the left ear at all, unless it's the guy's name. And even though the guy can't tell what language the other message is in, he does recognize his name about a third of the time. That should never happen, according to Broadbent's theory, and is really, as a matter of fact, quite devastating to it. The theory must be wrong. The theory says everything gets blocked from the meaning except one noise. But if the guy's name is carried in one of the other noises, on one of the other voices, he hears it anyway. That can't be if the theory is right, so the theory must be wrong. That's a really important point. Everybody get that? She tried that. I'm going to oversimplify this just to make the point. Let's say in this ear are single words coming in. Gentleman, fish from tree, goat, house, car, whatever. In this one is what's coming in that she's shadowing is Mary had a little lamb, its fleece was white as snow. And what she did was Mary had a little, and then the poem switched to the other ear. Mary had a little lamb, fleece was white as snow. Over here, gentleman fish from tree. So the messages from the two ears switched. Mary had a little lamb continued on the left ear now, and the string of words continued on the right ear. What the subjects tended to do was Mary had a little, and when lamb went over here, they went with it. Lamb, fleece was white as snow. Question is, how did they know that Mary had a little lamb was now coming out of the ear they weren't paying attention to? They're not supposed to be able to pick up anything coming out of the left ear, whether it's English or German, whether it's a man or a woman, but if it's a continuation of what they expected to be coming into the right ear, they all of a sudden understand it. Which also can't happen if Broadbent's theory is true. The critical flaw in Broadbent's theory is that the filter blocks everything from being analyzed for meaning except the one sound. Well, yeah, unless that one sound is your name, or unless that sound is a poem you were following along, and is therefore something you would really expect. So obviously, Broadbent's theory was a great start based on the information he had to go with, but it's wrong because the situation is more complicated. It's pretty much what you were saying. The filter doesn't just brute force block. It does something more complicated because some things get through. Very familiar things like your name, highly expected things like the completion of a nursery rhyme, they get through even if they are coming in on one of the blocked voices. Okay, so. Okay. Back up a second. Okay. The theory was doesn't block the sound of the other voices. Does not block hearing the sound of the other voices. You just don't understand them. The voices that are blocked by the filter are still heard as noise. I already said. They're heard, but only as noise. They're not understood because they get blocked from the understanding mechanism. Since the filter doesn't affect what's heard as noise, that must mean all of the noise information gets through. That's not blocked at all. So we can say anything about the nature of the noise, about the sound of the noise. What the filter does block is understanding what the noise means. It blocks understanding what the voice is saying. So that only one sound is understood for content. That is, since the filter does affect what's understood, that must mean the filter comes after noise analysis, but before understanding has taken place. The filter blocks noises from the understanding process. So only the one that gets through gets understood. Okay, having said that, here's our diagram again. This is analyzed as this this stores them for a few seconds. Then the filter blocks most of the stuff except for the one that the executive system sets it to pass through. It gets matched against long-term memory and gets recognized. But everything that the filter is set to block gets blocked. It does not get through. It doesn't tickle long-term memory system, which I've represented by 4 arrows here and only 1 arrow past that point. That's the bottleneck. That's where the flow of information is broken up. Now, problems developed. The problems that developed with the theory came about with this idea that the filter completely blocks unattended messages. Because, for one thing, sometimes the subject's name appearing in the unattended message would be recognized. And the question is, how do you know that noise is your name if you haven't recognized the noise? You recognize that as being your name without ever paying attention to it. According to Broadbent's theory, you should have never recognized that it should have just been a noise. But for some reason, you did recognize that particular noise. And the question being, how did you know that? How did you know to pay attention to that noise because it's your name before you paid attention to it, before you processed? And sometimes, this is the other example, sometimes the messages would flip between the 2 ears and the subject would follow the message to the unattended ear. Again, how did you know that was completing the nursery rhyme coming in this ear if it was completely blocked from meaning analysis? If you were just hearing a noise, how did you know that that was the continuation of Mary Had a Little Lamb?
Sure.
And according to Broadbent's theory, you just blinked.
Would it be the same case if, like, they didn't know, like, the nursery and if it was just random words and it continued to the other ear? Would it be the same case?
That would be possible, except it was too consistent. It happened too often, too consistently. That's why we do more than one test on a subject to see, because if something just happens once, who knows? That was coincidence or what. But if it keeps happening, not
so it
just
only
that.
happens with the recognized,
Right.
What if they kept like the same tone and rhythm, like Mary Had a Little Lamb, but you said something that was something different that didn't finish the phrase? You still be able to pick it up?
You would, if it was, well, yeah, if you mean, if one voice is saying Mary had a little lamb, a woman is saying Mary had a little lamb who sounds like she located down to your side, and then a God who's one.
Well, no, like if it's switched, like let's say like Mary Had a Little Lamb, and then like it switches to the ear, and I forgot what you're saying, it says something white. But if it's the same person, same tone, it's like Mary Had a Little Lamb, the boat out of the ocean. Or something like that.
That's what you would expect from Broadbent's theory, because it's following the voice. That's not what she found. She found that it followed the meaning, regardless of location, regardless of the voice. How is that possible unless you were paying attention to the meaning? Okay, so fatal problems for Broadbent's theory here. Either hearing your name in the unattended message should not happen, or knowing the message is switched should not happen. In fact, it would be impossible unless at some level you were understanding the message and weren't paying attention. Unless you were at some level understanding the message in the wrong ear, you wouldn't have known that was your name. You wouldn't have known that the story continued on that ear. You must, in some way, be paying attention to the other ear, even if you can't tell what language it's in. Some way, somehow, some level, you must be paying attention to that. You must be processing information from that ear that you're not paying attention. So, whatever else is happening, whatever really is happening, it's not Broadbent's original filter theory. There's something wrong. Two fixes were tried on this, and both of these theories are still around. Even though this is back now, we're getting into the early 60s. Some theorists tried to think of it by making the filter more complicated, by changing the nature of the filter. Treisman, who was, like I said, Broadbent's student, kept the early selection part of the theory, but changed her ideas about what the filter does. We do select by physical characteristics, as Broadbent proposed in his theory. But that's only one thing we do. That's only one thing we listen by. So at this point, Broadbent's theory was right. There just wasn't enough to it. But then, if that's not working, this is our basic kind of paying attention, but there's another kind of paying attention for high priority items. And there's another way we select for certain special high priority items. Some priorities are permanent. It's like we have a special list of listen for these sounds no matter what you're paying attention to. One of them is your name. Your name is on a special high priority list, and you listen for that sound even if the filter is set somewhere else. There's just a small, your baby crying would be another example of that. You have a list of things that are permanently important to you, and you process them even if they come in on the unattended channel. The filter doesn't completely block everything, it just weakens it. And most of the time, weakening has the same effect as blocking, unless it's one of these high priority items like your name or your baby crying or something like that. That gets recognized even with weak stimulation. Then, permanent priorities are always listened for. Sometimes there are current priorities for what you're doing right now. They also get checked, even if they're coming from someplace you're not listening to. In this case, once you start a sentence, you expect the sentence to end in a sensible way. And so if you hear the sentence end in a sensible way, even in a place where you're not generally listening to it, you still hear it. You still pick it up. Basically, the idea of the filter is right. but there are exceptions. One exception is when permanent priorities come in over a weakened channel. One is when momentary priorities come in over a weakened channel. Then they can get heard even though the filter is trying to block them.